Hello everyone. Today I will take some point of matrix to introduce you. The first I just tell you what is the symmetric, what is the screw symmetric, and what is the orthogonal and the quadratic form when we study in real matrix. So, in the first of our study, I just tell you something about the reason of uh, symmetric, screw symmetric, and orthogonal matrix. But the quadratic form I told you already in the first point. What is the quadratic form, and when we have quadratic form, we can find the real matrix. Matrix. So now if I have a matrix A, example, I have or we have a matrix. We have a matrix A equal to. So matrix A we can write A I J. A I J is said to be a real matrix. It's said to be a real matrix. A real matrix. And its element uh, is Aij, and matrix A. I write matrix A uh, is square matrix. Square matrix is square matrix. So A equal to Aij is said to be the first the first uh, it symmetric. Symmetric symmetric if A transpose or A equal to A transpose. It means that it means that Aij equal to Aj, and the and sum of symmetric matrix is we let by b equal to 1 over 2 A plus A transpose. This is the condition of symmetric matrix. And the think it screw symmetric. Screw symmetric if I write A equal to minus A transpose A, or A transpose A equal to A equal to minus A. So it means that AGI equal to minus AIJ, or AIJ equal to minus AGI. So and the sum of screw symmetric screw symmetric is divided by C equal to 1 over 2 A minus A transpose. This is the sum of our screw symmetric. And the third is orthogonal. And orthogonal if A transpose equal to inverse of A. This is inverse of A. And the determinant of an orthogonal matrix is positive and negative 1 because or since uh, 1 is equal to determinant of identity matrix, and it's equal to identity matrix is equal to A multiplied with inverse of A. So it's equal to A multiplied with A transpose. So it is equal to determinant of A multiplied with determinant of A transpose. So it can be right because A determinant of A and determinant of A transpose is equal. I can write A determinant of A multiplied with determinant of A. So A determinant of A and A, I can write determinant of A power square or square. So we get in this point we can take all these condition or property of determinant. So we get determinant of A is equal to positive and negative 1. So in this point A is an orthogonal. So the orthogonal of determinant of orthogonal matrix is plus equal to positive and negative 1. And the next, I just take some uh, example, so that uh, so that uh, any square matrix, any square matrix, any square matrix A can be written as the sum of a of symmetric and sum of a screw symmetric uh, symmetric matrix. So the first we have uh, the first I just talk only sum of symmetric matrix. So we have B B is equal to 1 over 2 A plus A transpose, but symmetric symmetric matrix is A equal to A transpose. So the sum of symmetric is also here. So we can write does, or I ask, does B equal to B transpose or not? Now we have B already. So B transpose is equal to 1 over 2 uh, A plus A transpose and transpose. So we got B transpose is equal to 1 over 2 A plus A transpose and transpose. And now we just write about B transpose. Yeah. B transpose is equal to 1 over 2. So A plus A transpose and transpose, we got A transpose plus A transpose and transpose. But A transpose and transpose is equal to A. So we get B transpose is equal to 1 over 2 A transpose plus A, or we write 1 over 2 A plus A transpose. So equal to B. Uh, Now we get, or now B equal to B transposer. So B is sum of symmetric, matrix. And one more about sum of Skew symmetric. Point two, I just talk about sum of Skew symmetric. Skew symmetric matrix. So we led by C. C equal to 1 over 2 and A minus A transposer. This one is the sum of Skew symmetric, but Skew symmetric. Skew symmetric is A transposer equal to minus A So this one I have C equal to 1 over 2 and A minus A transposer. Now I get minus C is equal to 1 over 2 A transposer minus A and C transposer is equal to 1 over 2 A minus A transposer and transposer. So I just write about the C transposer. I write C transposer is equal 1 over 2. So I can write directly in this point A transposer minus A transposer and transposer is A. So it is equal to minus C. So C is a sum of symmetric matrix. This one. In conclusion, just write about conclusion. B or sum of symmetric. Sum of symmetric B equal to 1 over 2 A plus A transposer and sum of Skew symmetric related by C equal to 1 over 2 A minus A transpose, because this one we have solving already, or we can certify already about this point. Now I take another example for you to solve some of this big. Just this is the formula of sum of symmetric and screw sum of screw symmetric. So I take another example. I just show that uh, A matrix is an orthogonal matrix where A is equal to minus 1, 1, 1, 1, 1, minus 1, 1, 1, 1, 1, minus 1, 1, and 1, 1, 1, minus 1. This is matrix A. Multiply with 1 over 2. So, so if A orthogonal, we have A orthogonal if A transpose equal to A inverse of A. So when we just write about this one, I think maybe difficult because A transpose is okay. We can write A transpose. It means we change from column to row and row to column. It means that you write only example Aij equal to AJI. This is A transpose. But inverse of A, you should find by our formula by determinant 1 over determinant of A and multiply with epsilon of A. So we find more about this one. The easy way to write, we just write A transpose. A transpose is equal to inverse of A. So I just multiply both sides with A. Just multiply both sides with A. So we have we have about I write in this point I just A and A transpose equal to A and A inverse of A. But we have A and inverse A is equal to identity matrix. So I just write A and A transpose is equal to I. I is identity matrix. So I write about this point. I just write A and A transpose. A and A transpose is equal to A is minus 1, 1, 1, and 1. 1, minus 1, 1, and 1. 1, 1, minus 1, 1. And the fourth row, 1, 1, 1, and minus 1. And A transpose, it means we change from row to column and column to row, is minus 1, 1, 1, 1. 1, minus 1, 1, 1. 1, 1, minus 1, 1. This one is 1, 1, 1, and minus 1. Sorry. This one A 1 over 2. It's A 1 over 2. And this one is 1 over 1 over 2. So we can just multiply 1 over 2 and 1 over 2 is A and A transpose is equal to 1 over 4. And we take this row example. I just take the row 1 with the column 1. With this column 1. So minus 1 and minus 1, 1, plus 1, plus 1, plus 1, 4 times is equal to 4. So I write this one is 4. This one is minus 1, minus 1, plus 1, plus 1 is 0. So I got this one is 0. And the next with row 3. With row 3, I just take this one. Minus 1 plus 1 is 0. Minus 1 plus 1 is 0. So I just write 0. 0.4 also is 0. So this one is 0. Column 2. Column 2 with row 1. Row 2 with column 1, column 2, column 3, and column 4. So we got this one 0, this one is 4, 0, and 0. And the next we go to column 3, to row 3. Row 3 with column 1. 1 minus 1 plus 1 minus 1 plus 1. So is equal to 0. Column 1 with row 3 with column 2. 1 minus 1 minus 1 plus 1. So is 0. 1 plus 1 plus 1 plus 1. 4 times is 4. And this one is 0. So we got the row, the first row with first column, second column, third column, and the fourth column. So we got this one is minus 1 plus 1 plus 1 minus 1 is 0. This one also 0. This one is also 0. This one is 4. So it's equal to this one we multiply with 1 over 4 is 1, 0, 0, 0. This one is 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. It is identity metric. Now we just have by the way of so A and A transpose is equal to I, or we can write A minus 1 power minus 1 A transpose equal to A power minus 1 I. So this one is identity metric. So I can write I A transpose equal to A power minus 1. So I get A transpose is equal to A power minus 1. If respect or followed by our property of orthogonality, now we get now A is an orthogonal. It's an orthogonal matrix. It's an orthogonal matrix. And notice that A is equal to B plus C. A equal to B plus C. So it means that the real metric, this one, it means that real metric is equal to sum of symmetric plus sum of Skew Symmetric. Sum of Skew Symmetric. And the next step or the next point, I want to take another example. Determine A, B, C. A, B, C. That A, matrix A is orthogonal. A is orthogonal, and A A is equal to 0 to B C. A B negative C and A negative B and C. This is a real metric or orthogonal metric. A is orthogonal. It means that what we have shown already, if A is orthogonal, we get if I write if A orthogonal we get A and A transpose equal to identity matrix. So fine. Now we find A and A transpose. A and A transpose equal to identity. So I write A, our metric A. Our metric A is A is equal to 0 to B C. No, we do not write A because we have already A. B A B minus C. This one is A minus B and C. And A transpose and we can write 0 to B C. A B minus C. A minus B and C is equal to identity matrix. Identity matrix is 0, identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, and 1. This is the identity matrix. And we just multiply A and A transpose. A and A transpose. Now we get this point. A 0 and 0. This is 4B squared. We got 4B squared plus C squared. And this one 2B squared minus C squared. This one is 2B squared minus C squared. This one is C 0 minus 2B minus 2B squared plus C squared. And row 2 with all column in matrix B. So we get B 2B squared minus BC. 2B squared minus BC and uh, a this one is a square plus b square minus c square. Minus and minus is plus here. And the next is a square minus b square minus c square. And the last row with all column is 0 minus 2b square plus c square. And this one is a square minus b square minus c square. And this one a square plus b square plus c square. So this one is equal to 1 0 0 0 1 0 0 0 1. So now we get uh, about 2b square minus c square equal to 0 and a square minus b square minus c square equal to 0 is none because it is non-diagonal element. Non-diagonal uh, of E. So at this point when you take this one, it means that you got C. This one is BC. Mean that you got this one is 2b square minus c square equal to 0. This one equal to 0, so you get this one is c square equal to b square. So you can take c equal to plus and minus b square root of b, and we have uh, a equal to, we take from this one, a equal to b square minus plus c square. So we got a square is equal to this one, c we got already to b, so we got b square plus 2b square. So we got a square is equal to 3b square. Now we write a is equal to positive and negative b square root of 3. And the next we from the diagonal. From the diagonal matrix, we have 4 4b square plus c square equal 1. So we got 4b square. C is equal to 2b square. 2b square is equal to 1. So we got b square equal to 1 over 6. So I got b is equal to plus over minus 1 over 6. So is equal to plus uh, square root of 6 over 6. This is b. And about a is equal to b. This is the square root of b. Square root of b. So I got a is equal to positive and negative 3 and square root of 6 over 6 is equal to square root of 18. I write 18 over 6. So this one is plus 3 2 over 6. So it's equal to 1 square root of 2 over 2. This is A. And about B, C. C C is C equal to B or plus B square root of 2. So it got this one is 2, this one is 6 over 6. If 12, I can write plus 2 square root of 3 over 6. So it's got square root of 3 is square root of 3 over 3. This is C. So we get the value. So value A is equal to positive and negative square root of 2 over 2. And B square root of 6 over 6. And C positive and negative square root of 3 over 3. If A equal square root of 2 over 2, B square root of 6 over 6, and C square root of 3 over 3, A is orthogonal matrix. And the next point, I just want you to find another example. This is another example about I want you to find sum of symmetric sum of symmetric, uh, symmetric metric from quadratic form, from quadratic form, I let by Q. Q is equal to x1 square plus 3 x2 square plus 2 x3 square plus 2 x1 x2 plus 6 x2 x3. So we have studied already about this point from our quadratic form. So we just convert. I just write convert from Q to A. A is a real metric. So I got metric A. Metric A is equal to, this one is 1, 1 and 2. x1, 2 is 2. 1 is 1. 1, 3 is 0. 2, 1 is 1. 2, 2 is 3. 2, 3. 2, 3 is 3. And the next 1, 3 is 0. 2, 3 is 3. 3, 3 is 2. So this is metric A. And the sum of metric A, sum of symmetric, sum of symmetric is B, equal to 1 over 2 A plus A transposer. A plus A transposer. So now we get A plus A transposer. I write A plus A transposer is equal to 1, 1, 0, 1, 3, 3, 0, 0, 3, 2, and plus transposer is 1, 1, 0, 1, 3, 3, 0, 3, 2. So it's equal to, this one is 2, 2, 0, 2, 6, 6, 0, 6, 4. And I got B. So our B is equal to 1 over 2. And this metric A plus A transposer is 2, 2, 0, 2, 6, 6, 0, 6, 4. So is equal to equal to this one is 1 1 0 1 3 3, and this one is 0 3 2 0 3 2. This is the sum of the sum of symmetric matrix, but B is equal to A. This one, because this one is A, the element of A. So this is the sum of symmetric of matrix A. And the next, I want you to find by yourself about just write like example. Find sum of symmetric symmetric matrix of 1. I just give quadratic form. 2 is equal to 6x1 square minus 4 x1 x2 plus 2 x2 square, and 2 the quadratic form q led by 2 x1 minus x2 square, and the third quadratic form is x1 plus x2 plus x3 square, and the fourth for the quadratic form is x3 square plus 4x1 x3 plus 2 x2 x3. So this find about the sum of symmetric matrix. So I just take in this point, and you can stop in here. I will take another point in the next of our next point for next video. Thank you very much for your watching this video, and practice. Don't forget to practice this exercise. Thank you. Bye.